So passage 3 is data. You're quickly going to get into the passage and look around, see what's happening. 20 to 30 seconds. It's like looking at a Where's Waldo picture. You see this is in space, there's asteroids, there's domes, they probably can't breathe, and then you're quickly to the questions. Reminder, our DRC approach. So for data you don't read, it might be easier to remember. Just don't read. You're going to quickly skim the charts and graphs and then go to the questions. So passage 3, greenhouse gases such as methane warm Earth's climate. So we're going to use something with methane. We're not going to read all this because it's a data passage. So we're going to see we have figure 1, which has solar radiation intensity over thousands of years, concentration of CH4 in the atmosphere, and solar radiation CH4 concentration in these lines as well. And figure 2, solar radiation intensity again, thousands of years, concentration and solar radiation and CH4 concentration. All right, and then we go to the questions. According to figure 2, the solar radiation intensity 8,000 years ago. So put your finger on figure 2, find solar radiation. So that's going to be the dotted line, 8,000 years. Put your finger on 8,000 years. I want you to draw a line straight up till you hit the dotted line of solar radiation and then over, and that's at about 500. So your answer is C. Number 16 is an if suppose why question. According to the figure 2, if the trend in CH4 had to continue to match the trend in solar radiation intensity, CH4 concentration at present would be. All right, so we're using figure 2, and we're going to say CH4, so the straight line, is going to match the solar radiation line. So at present, it would be less than 550. Number 17, we have another if suppose why question. Suppose that when CH4 concentration increases, a corresponding immediate increase in average global temperature occurs, and that whenever CH4 decreases, a corresponding decrease occurs. So CH4 is going to match temperature. Okay, which of the following graphs best represents the plot of the average global temperature in the past 11,000 years according to figure 2. Okay, so CH4, so our chart has to match this, and which one best matches that is going to be choice B. Number 18, based on figure 1, so we're going to pull up figure 1, the average solar radiation, so solar radiation is the dotted line, intensity over the past 250,000 years, we're using the whole chart, was closest to what? So draw a line right through the middle, and that looks like they're about the same on each side. So 480 is probably your answer. You can use the other two to process eliminate if you want to. 400 is way too low, 440 is way too low, 520 is way too high. So your answer has to be H. One solar radiation cycle is the time between a maximum in solar radiation intensity and the next maximum. According to figure 1, the average length of a cycle over the past 250,000 years. So find solar radiation is the dotted line, put your finger on the first maximum, and then it's between each one, right? So that's the difference between each one. You don't really have to calculate the average because they look about the same, right? So just do the first one. So from that one to that one is 20, and your answer choices, choice B is between 15,000 and 35,000 years. So B has to be your correct answer. Which of the following statements best describes the effect of CH4 on Earth's climate? So 1 or 2 will come from the reading or science knowledge. And so this one in the reading, it says greenhouse gas warms the Earth climate, methane. So does it give off visible light? No. Give off ultraviolet light? No. Cool Earth's climate? No. Warm Earth's climate? Yes. J has to be our answer.